everybody give a round of applause for more. Welcome to Sievert.
Hello. So yeah, I'm Jerry. As you can see, I'm just this guy. I'm a very proud cat dad. So the same thing is open if you want to come talk to me about cats or talk to me about my cat or see lots and lots of pictures of my cat. I am very happy to indulge. That's how proud I am. I'm a member of the Hydra engineering team. We build data warehousing extensions, columnar extensions, all sorts of really cool things. So I actually spend pretty much every day in Postgres writing extensions. And I am the maintainer of PLv8. I have been for 7 or 8, 9 years now. And due to that pain, I'll just say pain, that's what caused me to write PLJS, which is the successor ultimately to PLv8. So without further ado, you can see down there is a GitHub link that you are welcome to follow along. It's not going to be the whole presentation, but at least give you the links and talk about some of the things that we're doing. So what is an extension? I think that Jeremy got into it a little bit when we were talking about just setting up for the talk, but they can be functions, they can be operators, they can be types, they can be languages, and the language is actually, I threw together for the last time I gave this talk, which was about twice as long as I have allotted today. I pulled it out, but I did actually write a PL Lisp implementation, but we're not going to talk about it today. But we will talk about everything else. So what's the catch? Well, I'm talking about C extensions, so you kind of need a C compiler. On Mac OS, that's Xcode, Linux, GCC, and Make. Make is the basic system that, the build system that Postgres comes with. Windows, WSL maybe, I just don't do Windows. Some sort of Postgres dev package. When you're dealing with Linux, it's usually Postgres version-dev. When you install via brew, it's all there for you. And then some sort of text editor. And if you can type everything perfectly, I can't. But if you can probably even get away without a text editor. But I wouldn't recommend it. So let's talk about what we're going to be making. You know, in the olden days, before all these neat LLMs, we had something called soundex. Soundex is homonyms and word similarity, specifically in English. There are other implementations for other languages that are very similar, but it takes a word and drops it down into one letter, the first letter, and I'll go through the algorithm in just a few minutes, and then 3 numbers. So that allows things like John and Joan. They're fairly similar. There. You know, when you're typing, it's then doing a search, it's sometimes nice to have there and there and there, because we're not all perfect at grammar and spelling. And it's an oldie, but it's a goodie. So that's what we're going to be working with today. There's some boilerplate. Usually when you're writing an extension, as I said, the build system for Postgres is makefile, and there's a .control file, and there's a .sql file. And these are kind of important, and we'll get to that. In fact, we're going to look at some code, and I like looking at code. And as we pause, I have this code here. And when I mentioned the makefile, there's a bunch of little helper things that Postgres provides us. So if we set, let's say, objects, that's the things that Postgres will just go ahead and compile for you in the environment that Postgres knows and understands. Module big, there's module and there's module big. If we were writing this as just a single C file, I probably would just use module. That's what module's for. But we're using module big. We're linking two files together. So this is big. The extension, so what the extension is, the data, that tells us the SQL file that we're going to be including. I have it versioned. Regress, the build system has this whole neat thing for testing built in. And we will actually look at that because I have written tests. And then pgconfig, that's what is called, if you run pg_config on your command line, it'll spit out a whole bunch of things. And it's how Postgres has been configured, and it gives you all the information that you need. And then there's this neat little thing called pgxs, which when you run pgconfig --pgxs, it spits out the name of a makefile. And actually, let's see if I can type right. I can type, I swear. It spits out a makefile. And if we were to look at this, it's everything that Postgres sets up for you that you don't have to set up. So if I were to write a makefile from scratch for this, it would be at least this long. And so we just simply include that file, and we get all these helper functions and everything we really need to very quickly build an extension. So we also have this control file. Is that the, yeah, this is the control file, which is what Postgres uses in order to figure out which shared object to load, because these do build a shared object. That under the hood, it's all DL open, which is a POSIX subsystem for opening shared libraries and searching the shared libraries for symbols and all that other stuff that we thankfully don't have to care about. But this is all the information that Postgres needs. That we have a comment, that's for us humans, default version, and where it is actually loading from. So this libdir, when you install it, gets replaced with the actual library directory where all this stuff lives. And then soundx function is the name that we defined it's going to be. And then relocatable means that, yes, Postgres can move our code around. That's okay. Usually things are relocatable. And we map that with our SQL file, which actually creates this extension for us. So in this case, we're looking at a function. And this is creating a function called soundx. It just returns text because it's one letter, 3 numbers. And its language is in C. It's strict, which is fine, and it's immutable, which means whatever we give it, it's always going to return the same thing. So it is immutable. So if I give it Jerry, it's always going to return whatever the soundx is for Jerry that I don't remember. We can look at that in a few minutes. But just so we understand what we're doing, let's take a look at what soundx does. So soundx, from A to Z, again, we're talking English. 0 is a vowel. Everything else is a number that has some similarity to other numbers. So like T or C and K are going to be the same number because generally they're the same sound. So numbers that sort of sound like each other. And when we have a letter, we simply make it uppercase, and then we subtract, because this is ASCII. We can cheat. We can subtract the letter and look it up in this table. So A is 0, Z is 2, and then how the algorithm itself works is that until it gets to the end, or is less than 4, we can get the first letter, and then we ask what new soundx code is going to be. If it's the same, we just skip it. So we don't have J0, what is R? Now I'm actually curious. J0, I'm guessing probably 2. So it's not going to say 2.2. And we continue doing that until we have either the whole thing done, or if we're not done, we just append zeros, because who cares? So that's SoundX. This is going to be the basis for almost everything we do tonight. So it's good to at least understand that. But the function itself, this is our Postgres code. There are a couple of important things. Sometimes those pesky Postgres developers change something. They will move things into different header files. They'll change a data structure. They'll just do things to really screw up your day. They try to minimize it, and believe me, I am so grateful when they do. But every version is an improvement, and they're doing it to try to improve Postgres and to make it more maintainable, fast, and robust. So we kind of have to roll with it too. So they include a PG version num. So in this case, for Postgres version 16, some of the code that we needed moved into this varat.h. For everything older, we don't need that varat.h. So that's why we have this if here, to make sure that we include the correct include files. Postgres.h includes everything we need to get up and running. And Postgres.h should usually come first before any other Postgres include file. In this case, we're only using Postgres include files, except for our own SoundX file, which just simply defines the functions that we're using. So that's fine. Now, here's the really cool thing here. PG module magic. As I said, under the hood, Postgres is opening a shared object and loading it and trying to find exactly where the symbol, in our case, this function that we defined here in the SQL file, this soundx underscore function, it needs to find that in the symbol table in the compiled code in order to actually do something. So this PG module magic really does all that magic for us. It sets up the functions that need to be called. It sets up everything that we would normally have to do by hand just as a macro. And this, you only need this once in every extension, but you do need it in every extension. And then there's this PG function info call here, which I think if I hover, it will show us what it is. It's an export of the function as it gets expanded, and it's what pushes into the symbol table so that Postgres can find it and match it up to that name in the SQL file of soundx underscore function. That's all we need. From here, we're returning a datum, which is the standard Postgres data. It is some sort of data. We know what it is. We tell Postgres what it is because it's here in the SQL file. We're returning the text type, and we're expecting the text type to come in. And when we do that, when we do that, we get the response that we need. So what we're doing here, we have the soundx function. PG function args is another one of those macros that in this case, it's only the function call info. It's been different in the past, but this gives us all the information that we need in order to get stuff from Postgres. There's another great macro here, get arg text pp. So we're getting essentially a pointer to the first argument, argument 0, because we only have one argument coming in. We know it's argument 0. We're getting the length of the string, because this is a text data type, which includes, it's a varlen A under the hood. It includes a header of 4 bytes for the length, and then the data itself. And we're getting the length from var size any excluding header, because we know what, well, it knows what the size of the header is. We don't need to care. And then, so we get that information. We allocate a new datum essentially to hold the string that we need, which I like to null terminate. I don't know about you folks, but I definitely like to null terminate my strings. So it is the 4 characters from the soundex plus 1 null termination and the var header size, which, as I said, is 4 bytes, as you can see up there. And then we're simply calling the soundex function with the var data input, which is the pointer to the data where the header's been removed. And we're setting it to the output, the var data output, which is the pointer to the output with the header removed. And we're asking Postgres to please free up, if Postgres made a copy of the variable and did an allocation for the variable, to please clean that up for us. Otherwise, great. And we're returning a datum of the text type, a pointer to the text type, which is output. So let's go ahead and see what this does when we make it. It should just make. Okay, and there's also this make install, which installs it. And one of the things I sort of skipped over here is regress. Postgres build system also allows us to set up tests. So I've written some tests. Let's take a look at them. The tests are just a simple SQL function. And here we're calling create extension. We are selecting a soundex of John. We're selecting soundex of Joan. They should be the same. And then making sure a much longer word gets broken still into the same 4 characters. And making sure that there and there and there and there are all equal. Well, we would expect this to work, and in fact, we have this directory called expected, and it is the output of what it would have done. So we are going to try and make install check, which is another one of those nice things that Postgres does for us. It fires up a new copy of the database for us. It executes the SQL and does a diff between the two, and in 169 milliseconds, it has found that all the tests pass. So if we look at these results, you will see this is the output, and it sure looks a lot like the expected output. So our tests pass. That's great. We've just written our first extension. It's that easy. This isn't even difficult. Postgres makes it easy for us. There is one thing that I wanted to share, and that is that I have, and let me see if it's, there we go. Down here on this GitHub link, I have made these extensions available as GitHub templates. So you can just make a copy of it as a template, and it'll be your base for writing your own extension. Are there any questions on simple functions? Yes?
So if you don't use immutable, do you see a big performance hit?
You don't see a performance hit, but if it's not immutable, then let's say I add something that is, I'm trying to think of a good non-immutable without spoiling anything later.
The messaging system. You want to trigger or send something out.
So if something that's not immutable is when you send in an argument into the function, the response from the function can be different each time. If it is immutable, it's required to be the same each time.
Because we do something with the same parameter, we can have different results.
Right, yes.
So with immutable, for every value that you pass in, you get a very specific value out, which means that you can create an index on the output of that function call. So if you were using that function call as part of a join statement or part of a where clause, and you create an index on the results of that function call, it will use the index in that join or where clause. And that's one of the benefits of immutable functions.
So here for Jerry, it's J600. And if I were to pass in Jerry again, it should always be J600 because it's immutable.
So
But if it weren't immutable,
Postgres caches it somewhere internally.
it can, yeah. But if it weren't immutable, then it could pass back any random value, and that's not going to be good for us. I mean, it could be great, but in the case of this function, it's going to be not good for us. So I have Jerry is J600. Let's see what Jeremy is. J650. So we are somewhat similar, but we're not the same. Let me find, there we go. But
So you have to be the extension for all the platforms that you get, Postgres, Windows, Postgres, Unix.
you can just write the C code and the make file and the control file and the SQL file, and you can just, if your extension's written correctly, you can just build it wherever. It should just compile Mac, Linux, Unix, Windows.
But I mean, you have to create, if you want to make it available for everyone, you have to create them, become common.
Yes, and I will actually get to that part later in our talk. So, does everybody know what an operator is?
Yes.
All right. Well, I am still working with this Soundex here, and so I'm doing equality and non-equality. And for me, the operators are Soundex, yes, they sound the same. No, they don't sound the same. So that's what we're doing. So there and there should be the same. Jane and George should be the same. So again, we're going to look at some code.
You've invented your own operators,
I did.
to be clear, in case anybody was confused. You weren't supposed to recognize those and make sense of them.
No, those are completely things that I just made up the last time I gave this talk.
Can you increase the font size a little bit?
Absolutely.
Oh, that was that easy. It's
I'm going to make it a little bit smaller, if that's all right. But again, you'll see this is the same Soundex code here. Oh, I'm in the function template. Hold on, just a moment. Operator template. You'll see that this is the same Soundex code here, so nothing too exciting. Let's take a look at the make file. It's the same, except it's now an operator instead of a function. And let's take a look at the SQL code, which is a little bit different. So the SQL code here, we're still creating a function. In fact, we're creating two of them, equality and non-equality. And again, since it's an operator, we have a left and a right, and we're returning a Boolean value, so true or false on each of these. Now we can create the operator. So we're creating this operator, the equal, and we have the left argument is text, the right argument is text, the commutator is which is the equality, and our negator and our procedure is we're calling Soundex equal. I'm trying to remember what restrict is. I apologize, I don't remember off the top of my head what restrict is. The join is how the join is made. These are a few hints for Postgres, and we can deal with hashes and merges. We're fine with that. We're not doing anything that is scary for Postgres. We're doing another operator, which is the closed, and we have the same sorts of things, except it's the non-equal and instead of the equal. So let's take a look at how that code actually works. This should look a little familiar here, the PG module magic, because like I said, we do need that. But we're creating two functions here, equality and non-equality, and we're doing something similar, but instead of just getting the one single argument, we're getting two arguments. So we're getting left and right, both as text. And since we're not returning anything, I'm not going to allocate a text variable. I'm just going to use a nice little pre-allocated on the stack variable here, left and right sound X, and we have a bool result. So we are getting, no. We are getting the left sound X here, again with the var data any and var size any excluding header. I didn't break it out this time to get the length because we already did that, but it's just getting the length. And then our result, our Boolean result, is simply a string compare once we have the left and the right as sound X. And string compare in C, if it's 0, then they are equal. -1 is I think it's the left side, negative, or +1, I think it's the right side. Those could be reversed. It's been a while since I've looked at the string compare man page. But in this case, all we care about is equality. So is it equal? Well, we'll find out. And then again, we free and copy. And instead of returning a text, we're simply returning the bool datum. And this just simply, it's a 1 or a 0 is how it gets stored. And we're doing the exact same thing, but in reverse here. And we are checking for not equal 0. So this is our not equal. And then we are returning the result. And of course, we have tests, sound X operator.
Quick question.
Yes.
So you've obviously replicated a lot of the code here. Did you have to do that because of the way that Postgres calls into it? Did you put most of your code in a shared line, in a shared function?
Absolutely.
Okay.
Absolutely.
What have you done for Postgres reasons or for?
I did it for presentation reasons and to make these templates available to you so that you guys can go build whatever you want. Let's do operator template, and we're going to do a make, and we're going to do a make install check. Which it passed, but I should show you what the tests look like.
You need to make that video also bigger for the font.
I absolutely can. That. There we go. So here we are creating extensions. We are first checking the functions that we built because we are technically exporting these functions out as I showed in the SQL file. So we're doing the sound X equality. We are doing this should be false, this should be true. Then the non-equality, this should be false. So, and this one should be true because they're not equal. And then we're actually doing the equality check here. And our results, our expected results of these are true, false, non-equality, false, non-equality, true. These, with the operator itself, should be equal, true. And from the operator itself, this should be not equal, true. Not equal, false, because they should be equal. And not equal, true, because they are definitely not equal. And so from there, we have code that proves that our tests worked.
Another quick question about those. Did you have to, like, it didn't look like there was much about the operators in the C code, right? If you had written not the operators part in the SQL file, you'd just written the two functions, could somebody else come along and define those operators themselves?
Absolutely.
Using pure SQL without having to actually write an extension?
Absolutely.
Can you repeat the question for the recording?
For the recording, repeating the question. If I had not included the operators in the SQL file, could somebody just use those functions that were created and create an operator around them? And yes, as long as you have a left and a right, because there are two sides to the operator, and it returning a Boolean value, then absolutely you can write an operator for any arbitrary function that exists or doesn't exist in Postgres today. So Any other questions? All right, well, let's move on to types, because types are pretty cool, but we're still doing soundex. So this code might start to look a little bit familiar, but hopefully learning more out of it. And again, this is one of the reasons why I wanted to use the same soundex across everything, so we can speed through a lot of this without having to relearn everything. So in a type, let's take a look at the SQL file. So there are a couple of different parts to a type, because we are taking some arbitrary data in and we are storing it in some arbitrary way. And we have to tell Postgres that when we pass in a C string, that we are going to return some sort of type. In this case, we're returning soundex, which we'll define further down. And that does the conversion for us for storing the data in Postgres. And we have to have the reverse, where we pass a soundex, and it has to bring up some human printable, or somehow the database can understand it, whether it's binary or anything else, data, and return that. And then we're actually setting up this type here. So input is soundex in, output is soundex out, and we have this internal length thing. As I said in the very first function, I was allocating 5 bytes, 4 for the actual soundex and 1 for the null terminator. So we're telling Postgres that this type, when it stores it, however it wants to store it, that it's going to be 5 characters long. And there are other things that can do this, and I'm hoping that we'll have the time to cover it. But let's go ahead and look at that code. This is a little bit more complicated because of the soundex in and soundex out. We get the input, we get the length. Instead of allocating a text type, we're simply allocating 5 bytes. And this palloc, you've seen this. Palloc is Postgres alloc. Postgres keeps track of memory contexts so that we don't leak memory everywhere. It sets up nested memory contexts. And we're somewhere down here, and when Postgres goes to free up and says, I'm done with Jerry's code, it just simply destroys that context. So we don't leak. So we just use palloc. There's also pfree, which is very similar, but it does the freeing based in that memory context. And I'm happy afterward to talk about memory contexts if anybody's actually interested, but I'm going to skip over it for now. So we're getting the soundex of this, and we're saving it to the output text. Again, freeing if we need to. And we're simply returning a pointer to these 5 bytes because we did tell Postgres that we were storing it as 5 bytes. So we're just simply returning a pointer to it. And the inverse function of that, in our case, we already know we're returning a C string. We're storing it as a C string. As you saw, it's just a 5 bytes. So when we get this input, we don't have to do any translation. So we're just spitting it right back out to Postgres. So soundex out, whatever we have is what it's going to return. And let's take a look at those tests just to see what we do. So as you see here, creating a table. The table has data, and the data type is soundex. So what does that mean? Well, we can insert things into the table, and then we can select from it. And let's look at our expected real quick, just so we can see. In this case, we're doing the insert, and what's being returned when we do the select is exactly what we stored. H400, W643, J500, yeah, J500 and J500, because, you know, John and Joan, they should be equal. So we are actually just storing that, and Postgres is none the wiser because we told it it's storing 5 bytes, and it's giving us back those same 5 bytes. So let's go, going to make install, and make install check. And look at that, all of our tests passed, because it is actually storing that, which is kind of neat. You know, at least I think it's neat. But how do we get that code out to the rest of the world? It's hard. This is a hard problem, especially in the Postgres world, and a lot of people are working on solving it. There are a few different ways. There's PGXN, which is the Postgres extension network. This was done by an amazing gentleman named David Wheeler. It's been around for a very long time, and he is currently working on PGXN version 2. PGXman, which is another extension manager that it's a registry. With PGXN, it's just source distribution. It doesn't give you anything compiled. PGXman is a registry, and it gives you Debian and Ubuntu apt packages. No RPMs, but at this point, there is Trunk, which is a registry, and PGXN is, as I said, is working on 2.0 and is also working on Trunk. That's from Timbo. And then there's more showing up on a regular basis. So when we look at the code again, you might have saw that I didn't look at this meta.json. This is the PGXN JSON file, and it is everything that you need to know about it, and this gets it inserted into the registry. You can go to pgxn.org and create an account and then upload your own extensions, and they become instantly available on the registry. And you have an ownership to the extension, so you're the only one who can upload that extension, and it's quite helpful. In addition, for PGXman, there's this extension.yaml, which tells you how to build it and just a little bit of information that for the PGXman registry. This is what builds the extension into an apt package for you. It's a little bit more difficult. You have to have a GitHub account, you have to create a PR against the PGXman registry, and then you can upload it. So these really help with distribution, and this is an exciting space. There's more coming every day, and it's just kind of neat. But how are we doing on time?
It is 7:40. We started at a little bit before 7 o'clock, so we're probably at about 45 minutes right now.
Okay, I'm at sort of an inflection point here where I can show you something really evil that you should never do if you promise not to do it, but it will teach you just a little bit more about I saw the crossed finger over there. It will teach you a little bit more about extensions, and really don't do this, please. So does everybody want to go down that path? All right, I'm seeing a lot of enthusiasm in here. Okay. So a fnord is a word that essentially you're trained to not see or notice, that incites some anxiety, and when you're enlightened, you can see the fnords. I use this image. If you've ever seen the amazing John Carpenter movie They Live with Rowdy Piper in it, it has the absolute best fight scene of any movie in the world. If you haven't seen it, you should go watch it. It's good, but they have these aliens that are invading the world slowly but surely and trying to take everything over, and nobody can see where it says obey and that he's an alien unless they put on these special glasses. So to me, this is a really good way of explaining what a fnord is. So unless you understand and can see the fnords, then it's what it is. So we're going to create some fnords, and this is when you should really not do this. Where are you, other window? It is not there. Hold on just a moment. And it popped up on the wrong side. Hold on just a moment here. All right. As you see here, this is another type. We're creating a Finord in, same sort of thing, a Finord out. And you might notice one thing missing here. Anybody spot it? It's not immutable. This you should never do. Don't do this. It's bad. It can screw up Postgres so bad, but we're going to do it. And what we're actually doing on our Finord in is the same thing. Oh, there is one more thing I wanted to show you on this. You see this internal length where previously it was 5? Well, now it's variable because we can store anything. We're not storing just a soundex. We're storing whatever they send us and more. So in our case, we have this structure here, which is a structure called Finord. And I mentioned that the size of a variable length structure in Postgres is 4 bytes. That is this VLN array of size 4. And we're also keeping track of the insert time because we're being devious. And then we're keeping track of the actual value. And this flexible array member essentially tells the compiler that this value, when we allocate it, we're going to allocate it of some length, and to trust us, we know what we're doing. So this is pretty standard in the Postgres world, and actually a fairly standard construct in C, where you can allocate pretty much anything. Again, modular magic, we've seen this before. Finord in, Finord out. So we're taking C string, we're allocating the size of Finord, plus the length of the string that comes in, plus 1, because I like to null terminate things. And we're copying in the value, the input. We're setting the insert time, and this is gonna matter here in our non-immutable function here in just a moment. And then we're setting the var size, which is setting those 4 bytes up top to make sure that we're telling it that it is the size of Finord plus the length plus 1. And we're freeing the input, and we're returning a varchar pointer, essentially, because we're faking it, of Finord. So what if we, instead of just doing a straightforward return, what if we become a little bit devious here? And we check the current time, and what if, when we create that, what if we haven't waited 10 seconds? And 10 seconds here is an arbitrary time. If you don't become enlightened until at least 10 seconds after it's been entered, so you don't get your data back, so you're just not enlightened. But if we're past that time and you are enlightened, then we can actually get that data back. So we're allocating a value, which is just char, and we're returning the C string of that value. And I didn't even bother writing tests for this, because this is just horrible. Don't do this. I'm going to, I think I still have leftovers in here. Let's find out. I do. And drop the old extension, cascade. I'm going to drop the table F. I'm going to create the table with a value of the Finord type. Why am I? Oh, I did not. Thank you. I did not write the. So let's create that extension. Now you'll see here, it's warning us that it should be immutable. You can set those client messages to be lower than warning, so that you can even make the warnings not show up. But it's trying to warn us that we shouldn't be doing this, but we're doing it. So let's create that table again. Insert into F values insert into F values. Hello. Select star from F. We're not enlightened. We haven't waited the 10 seconds. Now we're enlightened. Don't do this. But I figured it helps show that how powerful and neat the extension system can be. And yes?
So this begs the question, why does Postgres let you?
The question was, why does Postgres let you do this? Because we're expected to know what we're doing. We're expected to be knowledgeable of what we're supposed to be doing. And it did warn us. You saw it did warn us. But we can create something that's not immutable. And we just shouldn't be doing it. But there is somewhere in the world, I'm sure that there's a use case for this, more than me telling you not to do it. So realistically, the warning should be enough to tell us not to do this, that we can probably safely ignore the warning if we're confident enough to do it. I agree with the Postgres maintainers that erring on the side of caution as opposed to just smacking you down is probably a better solution. So I'm actually quite happy that you can do this. So
a random number generator would be one that you would not have immutable.
Yes, a random number generator would be one that you would not have immutable. But time should probably be immutable. So
I would add to that too, that I think the Postgres project just generally has a posture toward, would you agree, Jerry? Kind of this sort of a posture toward, rather than like locking things down and being very narrow with like the whole extension concept and the whole idea of extensibility is it's just a lot of freedom and flexibility. Like we can't predict all the things that people might want to build with this and do with it.
yes.
It's kind of that posture, and you get a lot of places that I see of like they'll put the warnings, but they don't necessarily block it.
Jeremy just noted that the Postgres community does seem to have this more permissible, put the warning, but allow people to do what they really feel that they should do. Yes?
So the follow-up question is, C is not a language that is well known for its robustness. What happens if I dereference null inside my extension? Purely by accident, of course.
So the question, or starting with the comment that C isn't necessarily known for its robustness, what would happen if you dereference null? I've actually seen this show up on the Postgres bugs mailing list, and the answer is, quite rightfully, it will crash. And that's because that's an okay thing to have happen, is to have it crash if you're doing something dumb. Now there are more type-safe languages, such as Rust. There is an ecosystem to build extensions in Rust, which should help with this. About 2 weekends ago, I started writing Postgres extensions in Go, just because I could. I'm planning on putting up a template for that in the PG extensions repo. So there's a lot of other languages that you can use. Anything that essentially comes down to the C calling pattern, you can write a extension in it.
And just how it will crash means Postgres.
Yes, Postgres will crash, and and all the nastiness that goes along with that. So the idea is you want to write good, safe, clean extensions. Sometimes bugs make it in, and you have to just deal with it. But the goal is to write as safe and as good of extensions as you want, or as you can, because while you may be writing it to scratch your own itch, oftentimes you're also writing it for other people. And I mean, that's what I do in my day job, is I write extensions for other people to use. And PLV8 and PLJS are for other people. I haven't even done a database project other than storing my own local data, which is lots. So I don't even have the ability to use PLV8 or PLJS in my day job anymore, but I write it for other people. So when you write something, try to do the best you can. Try to fix the bugs. Try to share, and please, please open source it. Because when we build something, we don't just build it for ourselves, we build it for others, we build it for the community. And if you choose a good license, then it's great for everybody. It really, the rising tide raises all boats, and that's really what you're doing when you're writing and sharing extensions. So, did I see one more question?
Yeah, sort of follow on to the crashing question. I imagine you could also, like if you were taking your Fedora example, you know, when the indexer runs on that column, if you indexed it, like you're going to get very different data. Is that going to corrupt Postgres, or like it may not crash Postgres like the way that null dereference would, but you can still screw up other things beyond just crash the product. Right?
So the question was, in a nutshell, when you do something like this Finord, which don't do, I just want to say that at least one more time. When you do something like this, if you have an index on the column, can it ultimately screw up other things? And the answer is yes, absolutely. When you create the index, it will index the value of you are not enlightened. It will not index the value that comes to 10 seconds later. So when you do a query that's using that index, you're going to get bad results back. So there are a lot of reasons to not do this, and I'm hoping I'm enumerating enough of them to make you not do it, but it's something you can do, and it's something that if you have a devious enough mind that you could really screw up somebody's day. So anyways, if there are no more questions, oh, one more question?
Say one more thing. As Postgres in the newer versions have made it so that you can actually, via the extensions, change out the storage of Postgres. So you can create new storage styles, like column-based tables versus row-based tables. So the extension language is very, very powerful. You can do a lot with it, more than just what he gave as an example here.
And what he's talking about is table AM specifically, which I'd be happy to come back up here at some point and give a talk on table AM. That's what I do every day, is table AM, to store things in a different way and to be able to query them in a different way. But it's a lot longer talk than this one was, unfortunately, because there's a lot more to it. But table AM and index AM allows you to also create additional index types in a fairly easy way. And it's really nice to just change out everything underneath Postgres. It can be good, it can be bad, but it's Postgres is just so extensible that I don't even think I have time to even cover all the different types of extensions that you could make, let alone all of them in one go. Obviously, I for the brevity, I skipped doing a language extension, but I mean, obviously we know we can do that. But yes, table AM is, and that's table access method is the AM. It's awesome, and I highly recommend looking into it. And if you email me, which it's just anything at legitimatesounding.com, if you email me, and I'll go back to down there, then I am happy to point you to some reference table AM examples to help you on your way.
Does anybody have just any really basic? I know we've got people here all across the spectrum, from people that have been coding for a long time and folks who are brand new, kind of relatively new at figuring things out. Basic, simple questions just about exceptions of Postgres. We'll make sure everybody has a chance.
And by the way, you can do simple extensions too, just in the C language without in SQL language without writing C. But the C gets you all the more powerful functions and so much more that you can do.
You can also do it in JavaScript. Just saying.
Yeah.
That is kind of a question that I had mentioned, Go and Rust. Why did you choose C versus another language? And what do you recommend?
Well, in the mid 80s, I bought my first C compiler, and C was the first language that I learned on my Commodore 64 with the Abacus C compiler, and I've been writing C ever since. So I am just a C person. Most of the time these days, I write C++, and that is specifically to work with some very particular code that we are working with. So the interface that we have to some of that code is C++. So that's why I write in C++. And C. Rust is a newbie, fairly newbie, just the last few years of being able to build extensions in Rust. I've only seen one other extension in Golang, so that one's probably way out in left field. And it's just that's typically because Postgres is written in C. It's typically in the past what most people have written extensions in.
Do you find that because Postgres was written in C, it's more compatible with writing extension in C language, or extension is far removed enough that it doesn't really matter what language you're writing?
The question was, do I find that if it's written in C, because Postgres is written in C, it's more compatible? I think from the call stack, a low level, how the actual function calls are made across C is compatible with C, C++. There are some constructs that have to be modified for a Rust call. C is a stack-based language, so it's like the lowest common denominator. And so it makes it a little bit easier in that regard. Otherwise, you have to convert to a stack-based call system when you're actually calling back into C, and you're doing a lot of calling back into C from an extension.
Yeah, I think you're saying what I'm thinking, just in different wording, is some languages like PL curl, it has to load the interpreter up and then execute the code, so it's slower than if you did it in the C language.
So,
Cats start with C.
pardon?
Cats start with C.
And cats start with C, as do cookies. So, if there aren't any further questions, I'm Jerry. This has been fun. Thank you for coming and listening to my rambling, and I hope that you learned something interesting and fun out of this. So, and the equivalent of a mic drop here. Oh, it just kept up. I do not. Oh, I had the picture of her paws, but I don't have. That's all on my phone. I'm afraid. So, but she is cute.